Hi everyone, we will be explaining quantum superposition. This is an interesting phenomenon that explains how different objects can be in different states at once. This is Aaron, this is Jeffrey, this is Harrison. Let's explore some of its most famous experiments using a football. In our scenario, once we close the door, Jeffrey could potentially get hit by the football or not. But until we open the door and observe, he is in a state of quantum superposition, both hit and not hit at the same time. In quantum mechanics, the wave function provides a probability distribution for the outcomes of each possible measurement on a system.
The wave function is a mathematical description of a quantum particle and tells us all possible states the particle can exist in. In other words, the wave function is a cloud of probabilities for the particle with different outcomes and likelihoods.
In this case, our system is Jeffrey and the room that he is in. The function would tell you the probability of finding his state. However, when a measurement is made, the wave function collapses into a single state due to the observer effect. Here, if we observe Jeffrey closely and record him in this room, he'll collapse to a single state. He's either been hit by the football or not. Before the measurement, the object will be in a superposition of states. Another example is the double slit experiment, where we will substitute the electron for a football and the slits with doors. Imagine a player throwing a football towards a goalpost with two large doors. In the world you and I experience, we expect the football to go through one or the other door. If the football acted quantum mechanically, it could potentially go through both doors at the same time. If we throw the football over 1,000 times and mark each spot where it landed, the spots would look like an interference pattern similar to a wave. A car and a teddy bear. Now you close your eyes and ask your friend to put one of these toys into the box. Until you open your eyes and see which toy is inside, it could be either the toy car or the teddy bear. In a way, we could see that both toys are in the box at the same time. This is like quantum superposition, but for quantum particles. Now let's take this idea and apply it to computers. You know how your video game console has to think before it shows you the next level of your game? That's because it's doing a lot of calculations. It has to figure out where the enemies are, where the items are, and a whole lot more. The thing is, normal computers think in terms of ones and zeros. It's either this or that, but not both at the same time. Quantum computers are different. They think in a way that's similar to our toy box example. A quantum computer can think of the car and the teddy bear at the same time. It can consider different variables at once, which helps it to do calculations super fast. This has the potential to create a whole new world of possibilities for solving big problems like curing diseases and predicting weather accurately. We could even make video games that are more exciting and lifelike than ever before. But remember, it's also making it more challenging to keep our information secure on the internet. So scientists are working on creating new ways to protect our information using the same principles of quantum mechanics.
Mathematically, the state of a qubit can be expressed in the following form.
Oh!
Where A and B represent the probability the qubit is measured in the 0 or 1 state. They are also complex numbers satisfying this equation. This mathematical representation allows the qubit to exist in simultaneous states, 0 and 1. The concept of quantum superposition is far more intricate and profound than what we've discussed here. This is only the tip of the iceberg of this complex phenomenon. But that's all we have time for in this video. Thanks for watching, and here are some bloopers.
Viral.
Why are these two doors? These two are automatically open.
Oh yeah, that's can't catch though.
What?
Hey, can I see the script?
Wait, you start starting me.
He's the shortest one.
Wow. Let's go.
What? Jeffrey, you should go back if you're short. You can't like.